Hello everyone, I am Ahmad bin Khan, student of Fikra University. Well, I'm not an expert on car alternator, but when I acquired a car alternator as a project, I became seriously interested in how they work, the construction, the terminology, and all that. If we're going in deep analysis of car alternator, we have to know about some basic concept of it, how it works, what is alternator, why we use alternator, and why we use alternator. Basically, an alternator is an electromechanical device that converts mechanical energy to electrical energy. An alternator are rotating electrical machine used in a vehicle for generating electric power to charge the battery when the rotor of the alternator is turning at a sufficient speed. You can see here the alternator which I have right now is the alternator of Nissan car model number 9. The alternator which I have right now can generate 50 to 70 ampere current. You can have a simple view of this alternator. Well, the alternator is based on a several parts. Now we have some look of terminology of alternator. The alternator based on a several parts such as stator, rotor, IC voltage regulator, diode assembly, bearing, housing, pulley assembly, carbon brushes, and a slip ring. All the stationary part of the alternator is called the stator, and the rotating part is called the rotor. The coil of wire are used to produce a magnetic field are called the field, and coils that produce power are called the armature. This can be quite confusing because most of us equate the armature with the rotor. Traditionally, the armature was on the rotor, but this is not necessary in this case. The two terms are not synonymous. For example, in the common automotive alternator, the field is on the rotor and the armature was on the stator. The rotor and the stator are the mechanical configuration. The field and the armature are the electrical component. Either the electrical component can be located either of two mechanical parts. Now you can see here that I am opening that alternator. After that opening, you can see the different parts which I described right now. Well, I just described two parts of alternator. The other parts are IC regulator. Basically, our voltage regulator is an electrical regulator which is designed to automatically maintain a constant voltage level. The other of the part is diode assembly. The most common function of diode is to allow an electric current in one direction. But in the diode assembly, there are 6 diodes which are in the pair of 3. It is in the series of forward reverse, and a forward reverse. This diode is helpful to convert AC current into DC current. Now the bearing. A bearing is a device to allow constant relative motion between two or more parts. One of the most important parts of alternator is slip rings. A slip ring is an electromechanical device that allows the transmission of power and electrical signal from a stationary to a rotating structure. This is done via brushes and slip rings. The regulator output is carried by the brushes to the slip rings, and the slip rings are directly connected to the electromagnetic in the rotor. Basically, the slip rings have carbon brushes for making the complete path. Now, as I use the word carbon brushes, that carbon brushes is also present in this alternator. A carbon brush is the device which conducts current between the stationary wires and the moving part. It is commonly used in a rotating shaft. Well, that was the simple basic parts of alternator. Now we have to move some basic theory of alternator. An alternator generates electricity by the same principle as a DC generator, namely when the magnetic field around a conductor changes, a current is induced in the conductor. Typically, a rotating magnet is called a rotor turns with a stationary side of a conductor wound in a coil on an iron core called a stator. The field cut across the conductor, generating an electric current as the mechanical input cause the rotor to turn. The rotating magnetic field induces an AC voltage in the stator winding. Often there are three sets of stator windings. Then the current from the stator goes to that diode assembly, which converts that AC current to DC current. You can see in this alternator, there are three sets of diode in the series of forward reverse, and a forward reverse, which are converting that AC current into DC current. This alternator is based on a three-phase winding, physically offset so that the rotating magnetic field produces three-phase current, displays one-third of a period with respect to each other.